Hello and welcome to our video lecture presentation on SCRs or silicon controlled rectifiers, Diacs, and Triacs. We're going to first talk about an SCR or a silicon controlled rectifier. It is a 4-layered PNPN device that's similar to a 4-layer diode, except the SCR has 3 terminals. You have an anode, a cathode, and a gate. If we scroll upwards, we could see the symbol for a silicon controlled rectifier. So here's your positive end or your anode. Here's your diode symbol. Here's your cathode. And then coming off of the diode symbol is your gate. The gate has to have a positive trigger pulse in order for it to turn on. So when a positive pulse is applied, both transistors, as you could see in this equivalent diagram using transistors, will both turn on. In order for this to work, the anode must be more positive than the cathode. And if you achieve that, then once the trigger pulse is applied, then this stays on and doesn't turn off. Now we could set up an SCR because you don't want to keep something on forever. There are a couple ways to turn off the silicon controlled rectifier. The first is you could directly disconnect it from the source. So just by putting a switch in series with your silicon controlled rectifier, and by opening the switch, you're able to directly disconnect it from the silicon controlled rectifier. If there's no voltage going to it, then it's going to turn off. Another way to turn off the SCR is if we apply a positive voltage, and in parallel to the silicon controlled rectifier we put in a switch with just direct leads going to ground. Once the switch is closed, we would cause a short. Around our silicon controlled rectifier, so all the current would be diverted around the SCR to ground, and then that would be another way to turn it off. A second way to turn off an SCR is by forced communication, or by reversing the signal flow at which the current is flowing through the silicon controlled rectifier. So once the trigger pulse is applied, the signal voltage or the current coming from the signal voltage will flow through the silicon controlled rectifier as such in a downward motion. Notice here that the switch is open. So with this configuration, if we close the switch, what will happen is, here's our plus V up here, it will completely reverse the current flow where the flow will go upwards instead of downwards. And this will also stop the SCR from operating. So let's look at the silicon controlled rectifier characteristic curve. Okay, so in the off position, you're going to have very little current up until the breakover voltage. That's what it's called. Once the breakover voltage is hit, basically when that gate has a positive pulse going to it, now the silicon controlled rectifier turns on, and then it stays on until you either short it out or you directly disconnect it from the voltage source. Now, a silicon controlled rectifier only works for current in one direction. So if you try to set it up to go in the other direction, you'll end up having avalanche breakdown and you will ruin the component. So if you want a component that can conduct current in either direction, then you could use a 4-layer device called a Diac, which is an extension of the silicon controlled rectifier. It's also known as a thyristor. Here's what the symbol looks like. Basically, you have two diodes that go in either direction, so you have two anodes, anode 1 and anode 2. Notice that there's no gate connected to this. That's reserved for the Triac. So here, you'd see how this is set up. You have two pairs of transistors, a PNP and an NPN on both sides to handle current in either direction, whether if you want to set up your voltages down here and then ground up here, or set up your voltage up here and ground down here. Doesn't matter. So here you get mirror image characteristic curves for either side. So regardless if you hook up your voltage here, ground here, or vice versa, you end up with the same phenomenon. Once your anode is more positive than the opposite end, you're going to achieve breakover voltage, and then this is going to stay on and remain on. So let's look at a Triac. A Triac will combine the silicon controlled rectifier with the Diac, where this can work or the current could flow in either direction where you won't damage the component. And there's also a positive trigger pulse in order to turn this on. So once the trigger pulse is created, notice that I showed in red, it showed current flow in either this direction using these set of diodes where you have a positive voltage source up here, ground down here, or if you want to reverse it, where you put the positive voltage source down at anode 2 and ground your anode 1. I'll just show it as anode 1. Up here, then you would use the second half of transistors. And once this trigger pulse is applied, this will stay on, and it doesn't matter what direction the current flows, it's going to keep flowing until you directly disconnect it from the source. Now the question that you may have is, what is application of these type of components? Well, let's take a look at a burglar alarm. So a burglar alarm will have sensors, say at windows and doors. Now, if we look at the sensors of a window, say for instance, a burglar wants to walk through that sensor through the window once they open it or break it down. Well, as soon as they walk through and they break that beam that the sensor creates, that's only going to happen for a short amount of time. So if you don't have a type of device like this, the burglar alarm will go on while the beam is broken between the two sensors in the window, but once the burglar passes into the house, then it would stop. Then there'd be no more signal. But with a device such as this, using a Triac for instance, once that beam was broken, which is your positive trigger pulse at the gate, now it stays on. Now the alarm stays on. And basically the only way to break it would be to have some sort of switch, which you could have at the control panel of your alarm system, where you could have a deactivate function. You hit that, and then that will directly disconnect your Triac from the voltage source. But if there is a burglar, you want to keep it going on so that the police are called and notified. So that is a very good practical example of how a Triac could be used in an example. But that concludes my discussion on silicon-controlled rectifiers, Diacs, and Triacs. I hope that you found this video useful, and I wish you luck in applications using this. I hope this helps you out. That's about it. Have a good one, and I will hope to see you on for future videos. Bye-bye.